Hey guys, Jake here, coming at you with another math lesson today. Today we're going to continue discussing advanced differentiation techniques from my new book, The Elite Guide to AP Calculus AB. If you're taking AP Calc AB and want to get yourself a copy of that, go scan that QR code up in the corner of your screen or go check the link in the description or pinned comment below. But today we're going to discuss the next advanced differentiation technique, which is going to be the differentiation of inverse functions. So I'm going to be going through an example here. We're going to determine g inverse prime of 3 if g of x equals x to the fifth plus 3x plus 2. So really when it comes to finding the derivative of an inverse function given some function itself, pretty much the best way to proceed is just by using the formula. So let's go ahead and start with what that formula is. Basically, we know that if we are trying to find f inverse prime of x, that's just going to be equivalent to 1 over f prime of f inverse of x. Okay, so it really gives us a way that we can essentially find something different, I guess would be a way to put it. It allows us to find the derivative of, it allows us to find the inverse first and then plug that inverse into the derivative rather than trying to find the inverse of f and then take the derivative of that. Now, I'm not sure if that really makes a ton of sense in that kind of general scope, but let's kind of walk through the example. I think that'll help it make a little bit more sense. And you'll see kind of why that's actually helpful to be able to find this instead of this. So in this case, let's first just think about how to actually apply this formula to the problem we've been given. Obviously, we're trying to find the inverse of some function. In this case, we've been given g instead of f. Frankly, the name doesn't really matter all that much. What matters is that we're trying to find the derivative of that inverse. So we have g inverse and then taking the derivative of that and then evaluating that at 3 is essentially what this notation right here is saying. Same idea here, right? We're taking the inverse of our function f, we're then taking the derivative of that, and then evaluating it at some x value. So in this case, what this formula is telling us is what we're looking for is g inverse prime of 3, which essentially is just going to be using this formula, changing the f's to g's, and then changing the x to a 3. So we're going to have 1 over g prime of g inverse of 3. Okay. So here's where it gets, I guess, a little bit interesting in terms of why this is more helpful than what we were given. Because what this formula is telling us we need to do is find g inverse first and then plug 3 into that. So let's think about how to find g inverse. If we have this function g of x equals x to the fifth plus 3x plus 2, if we were going to try to find g inverse of x, we would essentially want to take this function, y equals x to the fifth plus 3x plus 2, switch the x's and y's, so we would get x equals y to the fifth plus 3y plus 2, and then solve for y, isolate y. Well, in this case, that's actually not really possible, right? We're actually, and you could definitely, give it a shot. I'm not going to spend time in this video doing that. But if you try to actually isolate y in this equation right here, it's not going to be something that you're going to be able to do. Not algebraically on paper. Maybe if you had some nice graphing software or something like that, you could come up with a pretty good estimate for that inverse function. But that's not something that we're going to be expected to be able to do on the AP test. So what can we do then? If we can't find g inverse, what other thing can we do? Well, think about what g inverse of 3 is saying. G inverse of 3 is going to give us some value, right? Theoretically, it should be able to give us some value. We'll just call it question mark. Well, what this is saying is if we have our original function g and we plug in whatever this value is, this question mark value, that should give us 3 as an output. So essentially this value that we're looking for, g inverse of 3, that should be whatever the value is for x that makes g of x equal 3 as the output. So essentially, instead of actually trying to find this inverse function, what we can do instead is set our original function equal to 3, the value that we're actually trying to look at here, and solve for x. So let's do that instead, because that's actually going to get us somewhere a little bit more doable. So what that would look like is, like I said, we're essentially just going to take our function g, so x to the 5th plus 3x plus 2, and set it equal to 3, the value we're looking at. And then we're trying to solve for x here. So there's a couple different ways we could do this. I mean, we could kind of simplify this, subtract the 3, bring it over. So x to the 5th plus 3x minus 1 equals 0. Now you're probably wondering, how can you actually solve for x? If we couldn't isolate y before in trying to find the inverse, how can we isolate x here? And you're right to ask that question. That's kind of the tricky thing we're stuck in. Well, the good news is we can use a calculator for this. What you can do is you can go, pull up your graphing calculator, and you can graph this function, y equals x to the 5th plus 3x minus 1, and then you can use the graphing calculating function of finding the 0 of that function. And if you do that, you'll find that x would equal roughly 0. And I'm going to write a lot more decimal places than maybe you need to, just to be safe. Usually I don't like to round long decimals until the very end of the problem. You want to keep as many decimal places as you can as you kind of work through the problem. Just because if you're rounding multiple times throughout, you kind of lose accuracy. By the time you get to your final answer, you might be a couple, hundredths or tenths of a decimal off from the actual answer. So, okay. So that should be enough. That's plenty of decimal places. So essentially this x value, this 0.3319 yada yada yada, is the equivalent of g inverse of 3. So now we can take this value and plug that in there. And what we know is our answer should be 1 over g prime of this. Okay, so then from here, we can actually find g prime. If g is x to the 5th plus 3x plus 2, we can actually fairly quickly find that g prime is just 5x to the 4th plus 3. And we can find that using the power rule, find the derivative of this function. Now this is our g prime, that if we plug this x value in for x, that should give us the answer we want. So 1 over 5 times 0.3319, and I'll just put a dot 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 for the sake of moving things along here, all to the 4th plus 3. Now note, when I'm plugging this into my calculator, you want to plug this full decimal in, keep as much accuracy as you can until you get to the very end. And if you do that, you would get roughly 3.0607 38622. And if you were on the AP test, presumably this would be a multiple choice problem. You would round this to probably 2 decimal places, and select your option A through E that most closely matches that. So that would give you your g inverse prime of 3 in this case. That'll be your final answer. So I hope you found this video helpful. If you did, do me a huge favor, hit that thumbs up button. Go check out my book, The Elite Guide to AP Calculus AB. You can scan the QR code up there. Go check the link in the description. But we're going to keep going through topics and problems in that book in the coming weeks and months. So be sure to subscribe, and I'll see you next time. Thanks.